Ladies and gentlemen, please take your seats. I think we will be starting in a couple of minutes. So, there's your preparation going on. Welcome to our office. For some of you, I believe for a lot of you, it's probably not the first time you're here. So how many people here are actually here for the first time? Could you raise your hands? Oh, it's actually quite a lot. Yeah, welcome. So, I gotta suppose you know where you are. We're Altenar. We are a major software provider in the world of iGaming, and we are dealing with tons of data. And I can tell you about this because my name is Ermakov. I'll be your host for today. And I'm actually a data platform team leader here at Altenar as well. And also, maybe a lot of you know that in about 10 days, I believe, right, we have Champions League. We also have World Cup coming, and it will be pretty challenging, right? We will have to process and store and deal with lots of data. Of course, I need to say that we are hiring if you are interested in challenges like this. And I'm specifically interested in today's topic that we have, which is data architectures and how do we actually approach dealing with huge amount of data. We have three wonderful speakers here today. And so maybe some of you have actually been here about a year ago, right? Because there is a tradition now, it's a tradition that every year, somewhere around May, Irina comes to Malta to also give a talk about something usually deeply technical. And this year is not an exception. So I guess without further big ado, let's welcome Irina to talk about CDC and all of that stuff.
Okay, good. Hi, thank you. Last year, I have been here with a bit complicated theme, and now it's a simple and popular thing, but with not a pleasure production story. So it is about CDC and till Failover do us apart. Just a few words about my role in Altenar right now. I am here more than 11 years. I worked as a developer, as an analyst, as a project manager, and now I focus on the databases and databases architecture. And I am involved in third-level support. So bird songs sounds really better for me than alerts. And usually means less trouble, as you know. And I don't believe in solutions, just should work solutions. So something can go wrong, just believe me. So I think some of you read a book about answer on ultimate question. And in IT systems right now, I see that it's CDC. You would like to use microservices. It's CDC. You would like to use data transformation, ETL, ELT processes for the data warehouses and so on. It's a CDC. You would like to audit your data. You would like to control who changed what. It's a CDC too. So looks like answer for any questions. And I think most of you heard about this technology. Who never heard about CDC? So it will be good. I'll tell you, and you will know after that. Who used it? A lot of you, okay. And who faced any issues with it? Almost all who used it. Yeah. In any conference and in a booklet, any texts, you can see that it's a pretty simple technology, like 3 steps, and you will get data anywhere. So at first, you track, so update, insert, and delete. After that, you track it in any log. Every transactional database has some transaction log in different forms. And based on this tracker, you put data anywhere. For example, in the Kafka. Kafka is some data flow, and you just track it from it. So it's simple. To be more specific, how it's going on. You update row in the database at first. But to be updated, you should have a transaction, and this transaction is put into the transaction log after it is committed. In general cases, not always, of course. And in this moment, some inbox technology or outbox technology track this change and put it somewhere in the Kafka, in separated table, in some technology. So it can work different. And why you need CDC in more technical and specific way, telling it. So first case, it's when you use ETL and ALT processes in your company. And in this case, you can use some alternatives. You can just select data, grab it step by step based on timestamp field, for example. You can use triggers. You can use outbox pattern, like this one. So when you have a separated table and rely on application that every change will be published in this table, and after that go to the flow somewhere, for example. If you need CDC for nearby real-time reactions, like, I don't know, monitoring systems, some fast reaction, notification system, acknowledge system. In this case, you also can use simple selects, you can use triggers, you can use streams, you can use queues, and so on. In case you need work with audit or tracking changes, you can also use different approaches. You can use triggers as well. You can use a raw version. You can use append-only system. It's not on the screen, but anyway. If you work with microservices or decoupling system, you can use database architecture. You can use streams, queues, also outbox. So different ways to do the same thing. But looks like CDC do all of it. And you just use it, and it works for all 5 cases that I presented. And how it works internally, it's for that guys who never met with this technology. So we have database, and database has log. Log file contains all finished operations of changing any data. This technology read these changes list one by one, put it somewhere, and actually after this, CDC is over. It's not CDC deal. It's a different architecture. But in most cases, when you heard CDC, you probably heard about Debizium. It's popularist approach for using CDC because it works with the most popular databases. It takes data as it is, put it into the Kafka in appropriate format, and you can do with it whatever you want. So Debizium is quite popular. But Debizium is not only one. For the transferring data or using CDC from the box, there are different approaches, like Amazon Data Migration Service, Google Cloud Migration Service, Azure Data Factory, Fivetran, and so on. So there are alternatives. But let's go deeper on the first part of this flow on the database. How can we read transaction log? Actually, this log of the operations can be much different in a different database course. And if we will use MySQL, for example, transaction log calls binary log. Binary log will be literally logged before you will be sure that you read it changes. So it's safe for you, but not safe, not pretty much safe for the transaction log disk. If somehow you stop reading these changes, database engine will not allow you to clean up this log. And you will face a growing log, overload disk, and so on. So it's possible. But you're sure that data are fine. If we will talk about Postgres, it's almost the same, but transaction log file calls val file. And this val file requires to create some logical slot to be read from this file. And it's a question about privileges, accessible, and also about how we can clean up this data in case of something goes wrong with your replication this way. Mongo database is also database. It also works with Debezium, but you can't rely on the transaction log file because it calls oplog, and it will be cleaned up instead of waiting when you read it. You can lose data, but you will have pretty clean disks. So good. And MS SQL, actually, it's a hero of our latest story because I faced last issues exactly here. It has transaction log. It works almost the same as MySQL and Postgres, but details, it's important. It doesn't allow you to read log directly. Microsoft reads its log itself, publicating data into the separated tables, and allow you to read only these tables. They doesn't allow to read it directly. It's important. So, flip side of this best technology is related with different issues that you can face there. You can face back pressure on disk, on system, on your production database. You can face data loss in some window during the switching, during the cleaning up the log, during other operations, maintenance, and so on. You can face ordering issues. It's simple. You have two tables, orders and maybe customers. Customers can be updated later than orders. So you will receive data later, and you can match them, you can link them. It's possible. Also, you will face issues with schema copying and changes. For example, you change your schema, it doesn't change from the receiver side. Welcome. Replication, not replication, reading and writing lag. So it's also possible because we use physical level here. And some duplicates, when you send something again and again, it's also possible. It's a nearby detailed list of the possible problems, and I can extend it a bit more. Where's the flow? So let's talk about MS SQL CDC. It's a story, okay. So technology presented in this picture, and it's official documentation of the Microsoft. So as I tell you before, it doesn't allow to read transaction log directly, so they created internal agent job to read this data and publicate it in change data capture tables, special tables. And they do it ourselves in technology after the switching on CDC availability. And you can read with select operations and so on, or Debezium can do it instead of you, from the final destination here. So, like Debezium work with Microsoft SQL Server, it's from Debezium documentation. Easy. No. What could possibly go wrong? Who uses it knows it. Log can grow, yes. Job dependency is important. You change schedule or you disable job, you will face issues, for example. Failover gaps, you switch off, log file is switching, so you lost minutes, some data go in a different flow, not matching, easy. Cleanup related with data loss, it's an interesting point. When you change your table, for example, you would like to extend something. You change this table, and you should switch off and switch on CDC. You can't do it in place. As you switch it off and someone updated a row, you lost this update. It's obvious. And of course, luck in this technology. So I marked what can go wrong, something like that. And we should switch it on, in some case, on production. I was worried about it. And I think about our systems that we should check some points before we will use it on production. So growing log should be monitoring. We should extend log disks, and we should take care about this. About it. Also, disk will grow because of CDC tables in. I mean, you have, for example, customers or orders table. It means literally that in the same database, you will have another duplicated table, and even more because updated 2 rows instead of 1 as you had before. And you will face I/O pressure. Probably it will also relate it with some CPU loading, maybe. What alternatives we can use in these cases in Microsoft technology? We can use temporary table or change table tracking. We can use triggers or CDC. So we started from comparison of the side effects on loading for each technology to decide what is more safe for us, what can we use easily. And we made insert tests and update tests. Insert test shows that CDC is less effective as temporal tables, but update test shows that it's better in performance vision. Based on this comparison, it's a load test comparison for a couple of hours with highest insert and update rates that we can allow, shows us that CDC technology has performance degradation effects. It related with CPU pressure. It is related with some performance degradation in a number of inserted or updated rows. But this these side effects are moderate. I mean, it's about 10 and up to 25%, and it's highly dependent of your data structures. I mean, it's not direct effect. Temporal tables has significant overhead during updates, and also this overhead affects on the speed of the update operations. And triggers, don't use triggers, actually. If you never use it, don't start. It's a rare cases when you really need it. It's a most dangerous case. So we planned everything. We took care about everything, except real production. You know, production brings surprises. So we configured CDC. We prepared monitoring for CDC. We deployed CDC. And 3 days, everything was fine. That's good. And after that, other team, other guys implemented security updates. And did failover from the primary node to secondary node. And after that, we receive log growing alert. Why? We checked everything. It worked 3 days. All was fine. I tell you about jobs. Microsoft technology thought that you shouldn't read our log. It's not safety for you. We will prepare a job for you, only on primary node. Only there. So we switched, no job fails, nothing alerting, but job doesn't exist. They doesn't prepare it. And we didn't thought about it, we didn't check it because staging was prepared 2 weeks ago. After that production, everything was tested on loading, but no one tested security update, you know. So that one bomb affect us. CDC is not an answer, it's a new question. It's a new question for you, new challenge for you, and every choice has a cost. I just wanted to show you on this really simple example that even most popular and most used in the world, I think, technology of the data monitoring, data transformation has its own issues. No, in IT or maybe in the real world also, no 100% safe technology is possible to build. So don't trust to marketing, just check everything yourself. Test on production, test on loading. Be very pessimistic. I was not enough pessimistic in this case. Test under loading, test how it fails. So implement all tests as you can imagine or even you can't. Monkey test is also a good idea. Monitoring all part of this chain. And good luck with this technology. So I don't know. I would like to say thank you to my team who was involved in all this stuff. So to Maxim, who is the lead of the database administrator team, Mikhail, who implemented that imagine tests with performance in certain update operations with all metrics and benchmarks. And Alexander, who actually was not involved in Microsoft SQL issues, but he faced it in a Postgres and us. Believe me. And thank you for your attention. Thank you for your time here. And if you have any questions, I would like and will be happy to answer it. Thanks.
Yeah, see, there was no thanks to security team who implemented the security patch, right? So just like some technical information for you guys who are actually watching us online, you can ask questions. I actually have them right here. You can ask them in chat in YouTube, and then that works. And yeah, so I can't see anyone because of the light, and I have a terrible eyesight. But if you have any questions right now, so raise your hands. I see a couple of, yeah, okay, let me come to you. Sorry.
Thank you. I'm a complete non-techie, so I'm here just to see what you guys get up to. Something which always strikes me here, you're dealing with big data, huge amounts of data, and I never hear the words artificial intelligence, Claude, or anything like that passing your lips. Why is that?
I can answer easily. Maybe 2 seconds. It's behind. I mean, we started from data sources that are not directly related with other technologies, why you use it. I mean, you put data in relational database at first. And to use it, for example, for artificial intelligence, you should transform it. You should transport it to that system. So it's a target. It's possible cause of using this technology, and you are totally correct with it. But I focused on a low level of the problem because it brings me pain, and I mishap that data warehousing, artificial intelligence, and so on solutions that are at the end side of this chain. So yes, thank you.
I've seen another hand here somewhere. Yes, no? No. All right. No, I actually want to ask a couple of silly questions because it is mostly about terminology. So one thing is, if I understand correctly, correct me if I'm wrong because you know about this more than I do, saying transaction log and saying write-ahead log. I believe in some databases they are the same thing, but in some they are not. Is that correct, or?
Yeah, it's correct. I mean, some databases rely on this log and write in it the change data. Some databases can be not so accurate with this log, and some databases just put their final transaction. For example, you update 2 million rows. It will be 1 row in this database, or it will be a number of rows in this transaction log. So it depends on technology, and actually it's a point of your interest to check your database type and how it deals with log file and with CDC technology as well. Yes, it's correct.
All right. And what about another question like this? Like, can we say that CDC in some form can be thought of as a way to do logic or not?
No. I mean, logical replication. No and yes.
Okay.
No and yes. Yes, because you can use it to replicate data, and actually you can use it, for example, for data migration or for update version of your database. So you just copy everything or replicate everything new, and after that switch versions, so you upgraded something to a significant jump in version, or even change database. It's possible. But in way that logical replication allow you to set up, for example, number of fields that you are replicating, or replicate part of data based on some rule, you can do it because you rely on transaction log, and it's pretty simple. Just read and drop in the Kafka. You can filter it out after that with receiver, but not from the box as it is technology. Yeah.
Thank you. And yeah, sorry, I keep stealing questions from you guys. Like, I know that one of the biggest challenges when setting up CDC is, in fact, synchronizing DDL. Right, like then we not only want to replicate the changes, but also changes in the table structure in the original database. So can you maybe say something about this, like maybe some story or
something that I can say in auditory? Sorry, not simple question. Okay, I already told you that there is an issue when you would like to update table structure. Yes, it is. And in some cases, you can switch on CDC technology if you have replication switched on probably availability group in case of MS SQL, and technology doesn't allow you to share transaction log with different technologies that you are using. So it can be a strong restriction in your case if you use other, not change data capture, but other technology that allows you to track changes. So it could be impossible even switch it on. Yes, correct.
Thank you. Yeah.
I'm worried.
Thanks. Hi, Irina. I just wanted to ask, as you know, with every database, when you create an index, you have some overhead when you have writes, when you have inserts and updates, and you do that to get some benefit when you're querying and looking up data. in your tests, have you compared the overhead of CDC to the overhead of an index? Does it compare? Is it worse? Is it not worse? CDC, does it, you know, the overhead that it brings, does it compare to an index, to an extra index, for example?
You mean, is side effects of using CDC compatible with using extra index on the same table in a performance meaning? I think it's a question, yeah.
Yes.
It's not a direct point of comparison, to be honest. I mean, when you use CDC, your target is to transfer data. If you use indexing, you speed up queries. But I've checked it in some cases in a practical way, and it depends of which index do you create. I mean, if you index one probably integer digital field, it's less damage than CDC technology. So it's easily to create such index. If you're using a complex index contains 5 fields, part of the fields are a text, for example, or even worse, some JSONs and so on. So it will be more damages in this way of using. And yeah, it's a good question because we can index in existing database, or we can put data somewhere else in a different structure and use queries at that place. So it's architectural decision. Use queries on the existing database and create indexes, or transfer it somewhere, for example, into the data warehouse, which is suitable for analytical requests, and proceeded there. So development is in details, and you should check every case yourself, and it depends on a lot of parameters of this situation. But thank you, good question.
Thank you. Any more questions here? Oh, all right. Sorry, I see we have a bit of a mess here with
You need more place to jump in auditorium, yeah.
Hi, thanks for the talk. You had a slide comparing the performance overhead of CDC. If I use a technology, a replication technology based on log shipping, like WAL replication on Postgres, or maybe Galera for MySQL, does that mean I basically get the data for free and can just capture it on another node?
No, nothing is free in this world. You know, it's something that make me sad from 5 years old. But okay, log shipping is a bit cheaper because you don't read it in general cases row by row, and you do it by chunks. Chunks are cheaper than row by row reading or writing. It's faster in transformation way because you read it from the log, put it in the Kafka. Okay, Kafka is fast, and read it from the Kafka. You know, it takes time, and also it's more specific for every database. And from my side, I think that it's more tested in different cases. So in most cases, you can rely on it a bit more than on from box suitable for every database solution like a DBZim.
For example, if I use Galera on MySQL, it uses row-based binary logs, I think, as well.
Yeah.
So where's the extra overhead if I do CDC on top? Do I need like separate logs for this?
For MySQL, I think no. I think it will share the log, but it should be checked. I never used it in this combination, to be honest.
Thank you.
Thank you. Good questions. And sorry, have you used it?
No.
No. Okay.
I come from the replication side. So, no, I haven't used it before. It's interesting to me because I come from the replication side. I have used MySQL Galera in production. So it's interesting to me to actually use database logs
Yeah.
with a different receiver than database.
Yeah. So yeah, that's clear. Thank you.
I also used myself on a combination with Postgres. Right? With Postgres, it can be quite challenging because I believe this is one of the databases which can be brought down by CDC, because so what basically you keep reading the log, but what happens if your CDC process fails, right? So there are two options here. One option is the database will start just dropping log entries, right? And you will just skip them on the receiving part. Or that node that you're reading from will start accumulating data, waiting for the receiver to reconnect to it and catch up. But that may never come actually, and they had some issues configuring this. I believe now they introduced like some basic timeout for it, right? So you still have some time frame during which you can restart it and it will work. But there was some release of Postgres where if you configured Debezium and it disconnected for a while, it could have been that the drive is filled with logs, with cached logs for Postgres waiting for the client, and it just failed, and sometimes brought down the rest of the cluster as well.
You should switch off replication, drop off replication on Postgres, and after that you can save database but lose data. It's only option, and in latest versions the same.
See, guys, like one of the best DBAs I know. Take your time and then catch her while she's here.
No.
So.
No.
All right, I think we can take a break right now. So we have a whole bunch of other talks today, and if you noticed, we actually put some thought into the structure. So now we're talking about CDC, and we're talking about basically synchronizing the changes from the database, which is quite often how these changes are actually replicated to, let's say, analytical database, right? We may have operational one, and this is one of the common use cases. So then we'll talk about, after the break, we'll talk about streaming data, right? We'll talk about the data buses and everything else around this, and also at the end we'll talk about data modeling in some final storage. All right, so stay with us, and yeah, feel free to ask questions online. Feel free to ask questions here. We have a bunch of food and drinks, and that's outside of the office. Feel free to help yourself, and I guess see you here in like 10 minutes maybe.
I'm seeing this. No, no, no.
But you're not seeing the presentation.
Oh,
If you change screen, that's the presentation.
fil-kasta minn OSD, jiena rrit nagħmel minn hawn. Minn wara. Dan kollox.
You got the presentation.
Yeah. If not, I'm going to put it on the USB. Put it. The only issue is there's no. Okay, here's also on the Mac now. But we appear here on the shit yet, Matana.
All right, guys, take your seats. We still have a lot of things to discuss and a lot of interesting topics to cover. So, I hope you enjoyed some drinks, some food. Back to the tech stuff, I guess. But I'll probably also say a couple of words about the team. So I wanted you guys to give actually a huge round of applause to the team that made this whole thing possible. That they are, holding this whole thing together, organizing translation, helping with the preparation. So thank you guys. It's really amazing. All right. So you probably already figured if you want to discuss any aspects of like data architectures, databases, you know where to find us. Or if you're interested, want to know more about Altenar, about what we do here. Maybe if you can help, you can also reach out to Agra, for example, and she's also here. She can help you. And yeah, as I mentioned, today we actually have a bit of a structure. So we've started with collecting the data, and then I promised you we'll be talking more about data bus and about streaming and about all of that. And I mean, it's kind of a liminal space, I don't know, for data, right? Like it's an intermediate space, but it's not only limited to just data transfer. It actually can do a lot of things. And I want to invite Matthew to the stage, and I'll tell us something about this.
Hello. Hello. Hi. Hello. Thanks for everybody for attending today. I'd just like to start to say I'm Altenar. I work at Altenar. I've been here for about a year now, and I'm the big data architect. I will not be talking about big data today, but I will be talking about the streaming part. And I do recommend that you always start from streaming before you go on your big data journey. All right. I'd like to also ask how many people are in here from a data area? Okay. And how many are we from iGaming industry? Okay. So I will be using a little bit of iGaming scenarios in my presentation, and to be interesting to understand how the streaming actually can be used for iGaming. Okay, so the journey will be basically through a bit of architecture. It will be about also different technologies related to streaming, mostly related with Kafka and JVM. We'll be talking about other technologies like Pulsar, Materialize, and also Rising Wave, and Flink, and also Red Panda, which is also another streaming engine. So we're going through a bit of technologies here, and we will be starting with the challenge. So basically today we are, unfortunately, or as the system is, we're building a bit of dumb pipes with very smart endpoints. So we're actually sending data across through pipes, and then we're actually storing the result in the databases, which then we do a result, or we actually develop an application. So we're actually doing something at the end of the chain, while we'll actually have the actual message itself is being sent over the stream. So we can actually use the stream to actually do some work there. So my definition of profit is saving time and saving energy. So every time I save time and I save energy, I'm actually making a profit. So I look at the data stream as basically a place where we can actually save time and therefore save energy and therefore make a profit. This is a standard architecture, I would say. We'll say a modern data architecture where we have the streaming layer, we have our data lake, we have our processing in Spark, Airflow, ML models. So this is the current, I would say, good state of an architecture. So we want to move a bit of a shift. I'm going to drive you to a bit of a shift in paradigm, and we would like to obviously do something with the data and the stream before it actually arrives or lands in a database. And this is the challenge we have. Why now? We obviously have a lot of processing now. We're hearing about this AI, and the AI is obviously bringing about a lot of CPUs and faster CPUs, faster memory, faster disks. Everything's faster, right? But we're not taking full advantage of what we have. We can do much more with what we have, and this is what I'd like to put forward. So as I mentioned, obviously the size of the chips are getting smaller and smaller, and we should be accelerating faster and faster our processing, but we are not exactly getting there. This is quite an interesting thing. So when I look at things, I tend to say nature has it best. So when you look at us as human beings, we actually have two reactions, I would say. One, if you put your hand on something hot or cold, you react instantly. While if you need to think about something, then you will be taking longer to actually do something. And this was actually tested. So we're saying 100 milliseconds for hot and cold reaction, and we're saying 200, 300 milliseconds just to decide to move your hand or leg. So obviously we want to try and get to the 100 milliseconds, right? To get instant, fast reaction. I'll just give you a small example. So a game in the betting state, so we have a baseball game and we need to bet, right? And in the betting, we would like to bet whether the person's going to pitch. The next one will be a strike or not a strike. Very fast decision making, very fast ball, very fast hit to the bat. However, we have certain software and certain systems that sometimes have a bit of a delay. Inside of them, they make a bit of a delay. And it can be like garbage collection or commit to the database. There can be a delay. So it's very important that we choose the right tool for the right situation. So obviously Kafka, as we all know, is, for example, one of the streaming softwares that is potentially used a lot. How many people use Kafka today on their systems? Okay. So Kafka is basically an event-based system, and it receives messages. So it can receive them from the Bezium, from the CDC, as we mentioned before, or it can receive them from the applications as well. So it's a very powerful, very popular tool that we use for storing messages. It is made one of the main engines it works for. It's actually developed in Java. It has a Java virtual machine, and they do a lot of strong work, I would say, a lot of work inside the Kafka to try and make it as efficient as possible. To the extent that they don't even use the Java virtual machine itself to actually process the messages. They actually use the cache in the OS to process the message. So they try, Kafka does try its best, put it like this, to try and reduce this delay. However, the Java virtual machine is there, and if you decide, for example, to encrypt your stream, Kafka will be sending the messages to JVM, and you will start suffering this latency spike. So do be aware that certain things in Kafka do end up, if you enable certain options, you start getting into the virtual machine. There is a big modern shift going on where we're actually starting to split compute and storage. So the reason being that you might need 100 nodes of processing and you might need 1 node of storage. So in Kafka's case, it does not do this split, but there are architectures which do it, and I will be speaking about them, so you'll know about them as well. I basically think of data architecture as 3 main pillars. We have the ingestion and the routing, which we can call the nervous system. All right. We have also the memory, where we're actually storing and synchronizing the data, which are databases, analytics, and these other systems. And then we have also the processing. Now, this is the part where we need to do more effort more in the sense we need to start using this area more, which is the brain, right? So we are obviously moving data from left to right, but we're not doing much with it in between. We can do much more. Yes, there is obviously a feedback loop where you can go from the memory back to the brain and back and forward. So, and the nervous system is consistently sending messages right across. So this is and these are the basic, the type of technologies we'll be talking about during this this talk. Okay, so we're going to start off with the nervous system, and the first topic is going to be Apache pulsar. I don't know if people have heard about this. Have anybody heard about pulsar before? Okay, two. Okay, so basically Apache pulsar is, I would say, the big boy in terms of actually working on processing streams. It has a separate compute and a separate storage layer. It was actually developed by Yahoo, if I get me correctly. And anyway, it actually is very, very scalable. So there's actually the bookers, which are the ones that receive the actual events, and there is the bookies. It is actually developed with a JVM, so it does actually have a JVM, but they do try again to avoid these little fallbacks again of the JVM storage. It is a multi-tenant approach, and when we say multi-tenant, we mean where you can actually have different streams actually inside the same cluster. So for example, if you have, again, I'm going to go back to the sports area. So if you have, for example, US sports where you have high volume and they're very bursting, you've got an event coming in, millions of people coming in at a point and then at a go, and then no events, we can actually push them through part A, and they will have their own compute, they will have their own storage, they will have their own way of working. Tenant B can be obviously European football, for example. They're consistent, they keep going all the time, and we part them through the tenant B part. And maybe we might also say, listen, that part might actually go to cold storage on S3. It also has a seamless historical replay, so we can actually replay back the messages that we received from any of the events and actually play them back for, I don't know, testing or for machine learning or whatever else we need. So it's a very, very powerful software. It is a bit more complex to manage because it's divided in three parts. So again, it has the compute layer, it has the storage layer, and it has also a zookeeper, which keeps the cluster in check. Kafka today has moved away from zookeeper, so they're using Craft. Anyway, but this is a software to contend with if you have you need to split the topics. So basically, I'm just giving a bit of an example of how you can pair different things working together. You can obviously use the pulsar, Apache pulsar, and you can use ClickHouse, which is an analytical engine. Both pulsar and ClickHouse are open source, so you can download them, you can use them when you want. And these are things which obviously you should do on analytical processing, not on a standard database. So I'm just going to show you how quick it is to create. Obviously, you install the pulsar, you get everything working, and then you go into ClickHouse and you actually create. You're actually going to start ingesting this data. So you're going to have a create table, which is pretty simple, right? Merge tree, which is the basic approach of ClickHouse. And we're going to get the events. We're actually preparing to get the events in here. Then we're going to create a stream. We're going to define the stream, define the engine, which is pulsar, the location, the topic, the type of subscription we're doing, which is the consumer group, the format, whether we're going to do it by row or not, and the type, in this case, is a protobuf, the message format type protobuf. And then the last step will actually materialize the target table with the stream, and we'll actually get our data in the ClickHouse analytical cluster. I mean, this is obviously a three-step simple approach, but it gives you a good idea of how simple it is to actually get some data from pulsar to ClickHouse. ClickHouse has a very similar approach for Kafka. So it is a very, very powerful engine, and I do recommend that you take a look at it. All right. Yes, I gave a bit of an example. So, for example, you might have a stream coming in, and you'd like to know who are the last players who lost more than 500 euros on roulette, for example, in the last 15 minutes. And ClickHouse will return the result within a few milliseconds, and you can decide to potentially give them a bonus or potentially check out what you'd like to do with these players. This is just a bit of a high-level diagram. So we have the spins and the odds, the push router and the pulsar in the middle, and the ClickHouse in the end. And then we can obviously query that data from ClickHouse, and actually send an SMS, for example. This is another interesting technology. It's called Red Panda. So Red Panda is a fully Kafka API compliant software. So you can actually put it instead of Kafka or next to it. It's not built with a JVM at all. So it's completely built in C++. It's multi-threaded, extremely fast, 10 times faster than traditional Kafka and Pulsar. So we're saying it's not a JVM-based architecture. And it has an ultra-low latency. So I would recommend it very much for anything you want to really be careful on response times. You cannot afford that delay, not even a 300 millisecond or 400 millisecond delay. You can use Red Panda. It's especially used for odds updating. So when we get the odds, for example, from the bookkeepers, or and you want to actually move them fast onto the front end. We mentioned obviously baseball. It's a very good idea to think of Red Panda. So you have the scout data, for example. There might be people who are actually inside the actual ground itself. We have the Red Panda, you have the trading engine, you have the user UI. So you have instant, a super car, I would say, in getting data from point A to point B, right? Okay, the next part is the brain, let's call it the brain. So we want to try and process complex events. So we call them SEP, okay? This basically Flink is an architecture that an actual software that actually sits on the stream. So you actually put it on the stream, and you're actually able to process events in window-based functions. So let me give you an example. Let's say we have a fraud. They being used for a lot for fraud detection. So we can actually use it to window the data within. So when the stream, the data is coming in, and we want within that window of time, we want to take an action, without it actually even ever arriving at the database. And from the stream itself, we're able to send an alert. And Flink allows you to do this. So basically it allows you to actually get the data from the stream, do something with it within a window of time, 5 minutes. I want to collect 5 minutes, I want to collect 10 minutes, and then actually send an alert or do an action with it. Again, it can be used for responsible gaming, for example, automation of losses. In this case, we have joining a bit of better diagram over here. We have the bets, and we have the match stream coming in. We have the window of opportunity, we call it, where we're actually joining the data and deciding how long we'd like to keep the data before we take an action, and then we're sending it to a dashboard. I'm going to give you the use cases because I understand this might be sometimes a bit high level. So if we have examples, we have 10,000 users and suddenly they bet on a specific bet. And within a 5-second window. So suddenly we have 10,000 users, they're betting on a specific bet in a 5-second window, and we need to alert the trading desk. We can also alert the trading desk, and we can also auto-suspend the markets for investigation. So from the stream, we don't even need to go to the database or to the application or to anything else. We can have a set of rules, a set of queries, or a set of developed Python code or some other Java program, for example, that actually takes an action instantly on seeing this type of event. This is just another diagram to show you. So we have the casino stream, we have the player wallet, going into this Apache Flink function, which is windowing, and it also keeps the state of the current user. For example, if the user has 10 bets, then he went up to 10,000 bets, there's obviously an issue. We can lock the accounts, and we can also send an RG alert. A second interesting use case can be, for example, a player triggers exactly 50 max bet spins on a slot game in precisely 12 seconds. I mean, there's no chance any person can do exactly 50 spins on every 12 seconds, right? So there's obviously some sort of a robotic script or some interaction, non-human interaction happening. And we can obviously suspend the session or block the user and obviously investigate why this game is getting these 50 spins at exactly 12 seconds. Is there a bug? Is there some other reason that's happening? And I mentioned before obviously the RG aspect, where you might want to, for example, if a person is escalating their bets, they're going from 100 euros to 100 euros, 300 euros. You'd want to maybe put in an RG automated trigger to give them a bit of a cooling off period for compliance reasons, for example. I'm bringing the technologies together over here, and I'm just again trying to point out how simple things can be. So if you have a Postgres database, for example, we mentioned the Debezium before. You're going to get the data from the Postgres database using CDC, the Debezium, which we mentioned before. And then, obviously, from the Debezium, you're going to go to a Kafka or a Pulsar or a Red Panda database. And then you're going to go, from that, you're going to actually use Flink. So these tools are all open source. So that you can actually download them, you can actually use them, and try them out. There's no cloud, there's no... just need a server and a set of machines. So this can be, for example, an event that I've seen many times in databases. So I've seen that we want to upgrade the VIP status of a customer. So we go to the database, the old approach, we go to the database, we keep polling and polling and polling the database on the deposits coming in. And then after an amount of window, then we actually update the status of the VIP. And the VIP would be potentially even higher than that or even lower than that. So we're not dynamic enough. We're not keeping up with changes. In this case, if we actually send the data across to the Apache Flink, for example, through the Debezium, we mentioned the Kafka, we mentioned Apache Flink, we were able to actually update it instantly. So Flink will actually send an update to Postgres to update it without having to pull the database and try to figure out which customer is actually going to be VIP or not now. So we have a rule, we have an action, and we have an event, which is the update of the Postgres. Okay, we're going to go to the last stage, which is the actual serving and the memory, where we're actually storing the memory. I know I mentioned a lot ClickHouse, I mentioned Debezium. However, there are some other technologies which are a bit quite interesting to know about. And there I would say upcoming databases. They're called streaming databases. And one of them is Rising Wave. You can find it again. It's an open source tool. Again, you can download it and you can use it. And these use incremental materialized views. There is also the option of Postgres. Postgres has a very good plugin engine where you can actually plug in different components. And there's actually one which is very similar to Rising Wave. But Rising Wave is a purposely built tool for this. So the materialized, I don't know how many people have used materialized views, but the way materialized views work today is you have to trigger a refresh. You need to requery the data. You need to get all the data again. And they're very, very tedious and very slow and time consuming. With the incremental model, with the delta change model, you just actually change. The only things that will change are the things that have changed. You don't have to query everything that didn't change. So it's extremely good for live leaderboards, for example. I've seen many sites where you go on the site and you say, but these are really live leaderboards, you know. there'll be fake generated boards, which won't be real. In this case, we can actually start to offer, with this type of technology, real live leaderboards. Top winner of a certain market, or certain events that we'd like to show a leaderboard of. We can also start to do maybe instant bet settlement instead of going through a whole transactional flow. Anyway, so there is obviously this streaming database will allow you to actually join the data coming in from the streams in a streaming database to materialize the data straight away, and then actually get it in a UI. There is also another, so the first one was Rising Wave, and Rising Wave works with a snapshot of time. So every 1 second, for example, every 2 seconds, every 3 seconds, every 10 seconds. But Materialize is much more fine. Let's call it fine. So this actually works per event. They have a guarantee. It has a guaranteed set of data, so it's like a transactional database, so to guaranteed updates. It was actually developed by Microsoft Research. So I don't know if you know, but Microsoft Research had actually released this database. But it's not a Microsoft product, but it's actually developed by Microsoft Research. It is not an open source tool, but you can download and you can try out, I think, 24 gigabytes of RAM and 48 gigabytes of disk space. And you can actually try it out. And this is actually real time. So this is what we'd consider the closest you can be to real time, while the other one is still a snapshot based approach. And we obviously have some examples to go through. So I'm going to, again, you can obviously summarize the data in Rising Wave, for example, and then store the result in ClickHouse or store the result in Postgres. So you do the processing somewhere else. You don't do the materialized views or the materialization inside a database, but you do it outside before it arrives to the database. We're talking about seconds to potentially minutes or hours difference. So there's a huge difference in performance here. This can be an example. For example, we want 10,000. We have 10,000 spins, and we want to calculate the 5-minute profit margin. Right? We've seen this example a few times. Most of the times we do it in ClickHouse. It's very fast, but you can even get it even faster with something like, for example, these materialized views. And then you can actually store it in the ClickHouse cluster, and you can actually do, you can save time and you can save energy by processing less. This is the example I gave of the raw events and the aggregations. Put it in the storage. We actually store the result in the database, the analytical database, and then we can do the instant analytics. You're also able to query. You're actually also able to query the streaming database straight away from the analytics engine, if you like, as well. So that you know it's actually a Postgres build. So it's actually Postgres client compatible. Rising Wave is actually Postgres client compatible, so you can use it. So anyway, the conclusion is do look out there for other tools, because there's a lot of tools out there. Do use the right tool for the right solution, and hope you obviously enjoyed the talk.
Yeah, let me exploit the fact that I have the microphone. So just to mention something, like I believe some people also refer to ClickHouse as, so you can, in fact, build a streaming database on top of ClickHouse, because you mentioned materialized views, right? And ClickHouse is one of those databases that actually supports automatic triggering of materialized views. You don't need to manually call refresh, but you can just write stuff to it and use materialized views on the fly to configure things. But I think Rising Wave and other things you mentioned, they are a bit more granular and a bit like more streaming-like, but still kind of the same idea. I wanted to ask, like, there is this also thing. So I'm really fascinated by this concept of actually thinking of databases as a stream of things, right? Because when in the first talk we already discussed that we have log of transactions, and at any moment of time, whatever we're dealing with is represented by this stream, right? By the amount of changes that we've processed. So I also remember that Confluent, the company behind Kafka, they've spent quite some time trying to make their own SQL engine and a lot of things working on top of Kafka. And I'm actually curious about your opinion on this. Would you say that it's probably better to keep Kafka as or something similar, for that matter, as a data bus, as a streaming solution? So it will be basically, I would even say, like a transport for things, or we can potentially try and use something like KSQLDB to compute stuff on top of it as well. So.
No, I do recommend that you use KSQL, for example. I do understand that it's a bit of a proprietary tool. Sorry?
At least for now, I think not fully.
Yes. So obviously it goes out of the open I would say sphere of influence, but it is obviously another amazing tool as well. You do get tied in a little bit with obviously Confluent in this case. So I tend to prefer, and in this case, the Patch Flink and the open source tools that are up there. Obviously, if Confluent decides to open source it and make it available to everyone, then potentially we might change our mind. But so yes, using the data in the stream, using KSQL, for example, is a good idea.
I believe Rising Wave is complete open source, right? It's
complete open source.
All right. Just to remind you guys who are watching online, you can ask questions in chat. And are there any questions here? Raise your hands. Okay. See one.
Hi, thanks for the talk. You started out by saying that you identified a bit of a paradigm shift away from dumb pipes, smart endpoints to some kind of a smart streaming platform. But you're obviously not arguing to make the actual message passing layer more bloated, right? In fact, you've rightly presented message queue solutions that are even smarter, even leaner, even faster, avoid the JVM overhead, and so on. So could you elaborate what kind of paradigm shift you're actually seeing here?
Yeah. No, the paradigm shift is that we actually do more before. So the shift we have today is that we're actually storing the data, and then after the data storing, we're doing an action. So the paradigm shift is, listen, we need to try and use the stream itself. We mentioned KSQL, for example. We mentioned Flink. We mentioned Rising Wave. We mentioned Materialize. There's a lot of. We also mentioned even ClickHouse has a very strong. Well, it's obviously landing in a database. So. But it has a very strong real-time aspect of aggregation, so within a few seconds. So the idea is to try and get as much as close as we can to the stream. So if you're actually able, I'm obviously talking about futuristic things, but if we're actually able to have like some sort of plug-in version of software which you can actually plug in the stream, like a developed Python code that is actually sitting in the stream, then that would be the ideal. So we'd actually have something sitting in the stream itself. So I hope to see a bit of a paradigm shift where we actually start to process things much before, basically.
To avoid storing raw data into a database, having it sit there, then get it back out, analyze it, rather than doing that, best to stream it directly into the processor, is what you're saying.
Yes, and also think about really, I was a DBA in the past for many years. And I used to see a lot of data coming in, and sometimes I used to say, but this data, why are we getting it? We don't need it. So, for example, let's take alerts as an example. So we get an alert, right? And we do an action on the alert. And then we obviously get a result. The result and the action is something that I want potentially to store. but do I need to keep all the log and there's a lot of information that's being kept that is maybe not beneficial, not useful. And then at the end we might end up having the alert sent late because the database is locked or glitching or overloaded. So I do feel that we can action things much before they land there.
Yeah, if I may also to add at least a bit, because that's also one of the topics that I'm dealing with about this paradigm shift. You actually mentioned this, Matthew, right? It's also in a way we think about SQL in these types of systems, right? Because before, if we're talking about OLAP, that means usually that we have to land the data, have it addressed somewhere, then we can run a query on top of it and get some result afterwards, right? But now with KSQL, with Rising Wave, with all these types of systems, I would say that one of the things that kind of shifts the paradigm a bit is now we see the SQL as not something, running on top of data at rest, that we just wait for results, but something that works on top of the data continuously, which continuously arrives. Right, so we had a prototype of this, for example, with how streaming works inside of Apache Spark, right, where we have like an infinite data frame basically, and when we run a SQL query on top of it, it just keeps appending rows and keeps processing them. And it still follows the same idea, I believe, right? Like we have a sliding window, and we keep running that query in, this kind of sliding fashion, recomputing things on the fly. And this is what makes it really interesting, right? This is why this whole concept of streaming databases exists. That's kind of my 2 cents. Yeah, sorry.
Yeah, I mean, obviously challenge the status quo, right? The status quo of potentially doing everything in the database. We can do it potentially before. So this is the thing, right? Any more questions?
Raise your hands. Yep, I see.
Thank you. That was fascinating. Your concluding slide is winning the race to zero latency.
Yes.
And one of the early slides, you showed the baseball in strike.
Yes.
And you said that if you have a latency of 300 milliseconds, it creates the opportunity for arbitrage.
Yes.
What on earth
Yes.
is at the other end taking advantage of 300 milliseconds to make a profit on an arbitrage?
Yes. So basically, when we look at delay latency, you must not only look at one item, you must look at the whole chain. Now, when you actually get the program, the user interface, the stream, the database, and you get the whole layer of transmission, you'd be amazed that even a slight, like 100 millisecond on the whole chain, throws it off just enough of time for somebody to actually take advantage of you. So what I'm trying to say. So they don't actually do it in 100 milliseconds. So this is maybe why the misconception is. It's just the increase in delay that we experience, because we'll be experiencing, you have to appreciate that we don't have one bet. We have potentially a million, right? A lot of bets coming in. So if we have a 300 millisecond on each one, you can imagine how much it hurts us. And this means all the bets coming in and all the information coming in starts getting delayed. So the latency, I would say, on even simple queries and in databases, for example, in everything that we do, latency is a big killer to us in development, in processing. It's come to, even for example, and just I'm going to go at a physical context. For example, in chips today, we're going smaller and smaller, right? We're going from 5 micron to 5 nanometer to 2 nanometer. And what they're gaining, if you look at the documentation, is that they're getting them so close to each other, right? That the actual distance of light or electricity, in this case the electron, to travel from one chip, one transistor to another is getting shorter, so they're gaining time. So the time they're gaining means we're processing faster. They are getting to an extent that even they're thinking of putting, for example, copper fiber now, glass, between the chips to make it even faster. So I personally think one of the most important things for an engineer is to take care of time. Because with time, if you multiply it by 1 million events, 100, 100,000 or whatever, an amount of events, they add up.
Yeah, I have one of my favorite stories. It's actually about information security, and they have these types of competitions where the companies, the teams, they are competing in retrieving flags, which are like some random hashes, like strings, from the servers and submitting them to the leaderboard, right? And there was a story where the second place was taken by a team that successfully retrieved all the flags, and they successfully submitted it. The first place was taken by the team which put an exploit in the laptops of the first team. So they stole the flags once, the moment they were downloaded to those laptops, and did that in like a split second before they've actually submitted it. So they submitted them first, and this is how they won. So, I mean, all kinds of weird things can happen.
Thank you for so detailed presentation, but I would like to go a bit deeper. Could you please go to 38 slide? 38. Sorry. Yeah. Okay. Yeah, it's almost the same picture, and I am interested in materialized view and its speed. I mean, in my reality, I thought that materialized view takes a lot of resources, and actually it's slow technology independently of how often you calculate it. I mean, if you update 5 source tables, it leads you to update heavy view at least. And you are talking about some good performance. So question is here, have you tested?
Yes.
Yes. And can you, I don't know, explain or maybe imagine how it works on a physical level, why it's so fast?
Yes.
Thank you.
So basically, Rising Wave, let's take this one as an example, they work with deltas. So they actually keep track of the changes that are happening in the data set. And they actually only update those deltas. So while the materialized views that we have in common databases tend to update everything that there is inside the materialized views, the Rising Wave does it through deltas. It is extremely fast, I would say, and it is a better way than calling computing materialized views. There's also another issue, depending on the database. So, for example, I know that some materialized views during compute, during refresh, they actually lock, so you can't even access them. I know that Postgres has an option concurrently, where you can actually put it as a concurrent materialized view. However, it is still basically much slower than Rising Wave, and in fact, I do recommend that you use a special type of component. Basically, in Postgres, you can add components in the database, and one of them is specifically for a sort of like a copy, or let's call it like similar to Rising Wave. It's not as efficient, but it can also be used in Postgres. Postgres has a lot of like PG cron, PG, I think ICW. I forgot the name exactly of the Postgres component, but it's a good data, good to use. I just want to ask you something. How many times have you had any issues with with any materialized views in databases. Have you ever come across any performance issues yourself with databases?
Yes. At first, in insert operations, I mean, if you have materialized view, which should be available at the same time as you made an update, for example, it takes time, and the worst case, if it's good indexed materialized view. So because of it, I question you.
Okay.
Yeah,
And if I had to tell you, would you prefer them in your database or would you prefer them out?
I don't know.
No. So obviously, I understand that if you're obviously processing in the database today and they're causing you slowdowns or performance CPUs and
So just
if you move them out of the database, then you don't have to deal with them anymore, right?
Yeah,
So,
I will be happy.
Well, exactly. So I think that this tool is a good solution for you to consider if you have obviously materialized views in your database and you're suffering from
It's
performance issues,
an
right?
argo. Thanks.
Thank you.
All right, thank you. I think we can take another break now because thanks. First of all, a huge thanks to Matthew. So let's take another break, about like 10 minutes, and because we have one more interesting thing to talk about. All right. So we have another talk. Well, I mean, I already told you guys. So today is all about data architectures, and we actually have a special guest today. I mean, in Malta, it's probably hard to surprise people by saying we have a guest from a small island, you know, like some small, say like island in the north. I believe it's called Great Britain, right? Like a tiny place. So, yeah, I believe we'll be talking about data modeling, especially which usually happens after, you know, you've extracted the data via CDC, you've written it, you've sent it through some data bus, maybe did some like stream processing. Now it's time to store it, to model it, and yeah, let's give it to Evgeny.
1, 2, 3, 3, 2, 1, 1, 2, 3. You can hear me, yes? Okay. Yeah, thank you. Thank you for being here. I understand it's getting late. I'll keep it short, brief, as much as I can, and useful. I hope it will be useful. So, at the start, briefly, a little bit about myself. So, I hold PhD in field of database systems. I have been working with data for more than 15 years, and now I run a small consulting agency. So, I help some organizations to make their data platform better. However, everything I'm going to share with you today is related to my last working experience. It's Toloka.ai. Toloka.ai is an AI-focused startup, so I was head of data platform there. And I also want to mention Leonid and Nikita. I think most of what I'm going to tell you was made with them or by them, so I'll share all the contacts. Feel free to reach us if you have any questions. Here's our plan. So my presentation have a main question. How can you organize and manage DBT on your own infrastructure without paying for DBT Cloud based on Toloka experience? First of all, I will briefly go through retail tools, retail Airflow DBT, just to be sure everyone here has the same context. Then I'm going to tell you about DMPIF. It's our way to integrate Airflow DBT. It's our integration library. And last part, I think, will be the most interesting because I will be going to tell about how we adapt our platform for agents, for Cloud, Cursor, and etc. Our takeaways, your takeaways from my presentation. Of course, you can take approaches to repeat because it's repeatable. You can take it and repeat it at your own workplace, or you can use a ready-to-use open source solution because we open source at our library. Here you can see the link to our GitHub repository. Feel free to download it. Feel free to open issues. Feel free to give us a star if you find it useful. You also can check our site, small funny site with documentation and examples. So feel free to use it. Let's start with the main part, retail tools, and a small question. Who is a data engineer here? I am a data engineer. Not much. Honestly, I'm not a data engineer anymore. I'm a consultant, I'm a manager, but I was a data engineer, and I think everybody knows what ETL is. So ETL, extract, transform, load. ETL pipelines is a core part of data engineering work. We extract data, we transform data, we load data. So there are a lot of ETL tools and orchestration tools, hundreds, maybe thousands of them. A few of these tools are on the slide right now, and of course I want, but I don't have enough time to speak about all of them, so I will focus on DBT and Airflow. Why? Because these tools we used at Toloka.ai. So I will start with DBT. DBT is a command line tool that allows analysts and data engineers to transform their data in the warehouses using select statements. So DBT is responsible for T, for transformation, if you're talking about ETL. DBT has a lot of awesome features. Data lineage, version control friendly, works on top of modern warehouses. Honestly, I'm a big fan of DBT. So I have been using DBT for many years in several projects. And in my opinion, any data specialist who should try DBT at least once. because it's awesome tool, believe me. Let's go through simplest DBT project. On the slide you can see DBT project structure. It consists of several files, several configuration files like DBT project YAML with main configuration, profiles YAML with connection settings for the data warehouses, etc. But the main brick, the main entity of DBT project is DBT models. It's a SQL models that define the transformations and business logic. So now on the slide you can see the example of DBT model. As you can see, it's select-only statement. DBT uses Ginger templating, so we can use some macros. For example, we should reference other models using a ref or source macros. So this is a way DBT knows our dependencies between models. Maybe you can have a question, how can we transform data without insert, update, or delete operations? The answer is DBT materialization. So materialization is a strategy by which DBT executes SQL queries. It can be a simple one like create table, create view, or it can be some advanced like append, merge by key, insert override partition, and so on. So a lot of materializations. As I have said, DBT is a CLI, command line interface, so it provides a range of commands for running models, testing data quality, and so on. So I'll go through the main or most common commands, build, run, test, and docs. So the main command is DBT build. It builds dependencies between models and compiles SQL queries. So the result is written to manifest.json, and after the project has been built, we can run on our models. DBT run, it executes SQL queries based on provided parameters by model name, by tag, by folder, and especially I love by dependency graph. It's hidden, but it's by dependency graph. So I can run model and all children's, all parents, or both of them. After we get our database, our table into the database, we can run DBT test. So it's a command used to validate data quality. It runs tests like checking nulls, checking uniqueness, checking relationships, and so on. There are a lot of tests. Last but not least, DBT docs. It generates documentation. Here on the side you can see the example of lineage documentation. And it looks pretty nice, as for me. So you might have a question. DBT seems cool. What's the problem? Let's use DBT and that's all. But there is a problem. The problem is that there are no options to schedule a task in DBT core. DBT core is open source version of DBT, and you can't schedule a job. If you want to schedule a job, you have to pay DBT Cloud. You have to use DBT Cloud. Okay, and here on the stage comes orchestration tools. So we have another option to schedule something. It's orchestration tool, and Apache Airflow, as for me, is mostly known orchestration tool in the data world. So there are a lot of features at Apache Airflow: workflow scheduling, pipeline orchestration, integration ecosystem, and etc., etc. The main brick, the main entity of Airflow, is Airflow deck. We can set a schedule for our deck when the workflow should run. We can set tasks. Task is a discrete unit of work at Airflow. We can set task dependencies, and all of these can be set using Python. As you can see here on the slide, it's like a simplest deck with two tasks, Airflow, hello Airflow. Yes, hello Airflow. Here is the presentation of this deck at Airflow. Honestly, I don't like this slide. Don't watch it, because it's not fair to compare Airflow and DBT. Airflow and DBT, it's different tools. It solves different problems. So I don't like this slide, but the main conclusion of the slide that we can use both these tools together. DBT is the SQL-based transformation inside warehouse. Airflow is used for workflow automation orchestration. We can use both of them. Airflow manages scheduling, DBT handles data modeling, and the only question, the only problem, is how should we use them together? So it was a question, it was a problem we faced at Toloka.ai several years ago, and our answer is DMPIF. It's our library, it's our way to integrate DBT and Airflow. On the slide right now, you can see our Toloka data platform. It's based on 3 ideas: data lakehouse as an architecture, data mesh as a processes, and modern data stack and technologies. And there are 4 main tools: Databricks, dbt, Airflow, and Tableau. So, how did we integrate dbt and Airflow? The main idea is very simple. It's pretty simple, as for me. It's very simple. We already have a graph in dbt. And based on it, we can create DEC and Airflow. And that's all. Use dbt build. dbt build generates dependencies and write into manifest.json. We can read this manifest.json file and generate Airflow DEC based on dependencies. So it's simple. We can do it and get DEC looks like this, for example. Let's go through tasks. You can see here, simple model task is just dbt run model. So we use dbt clean, dbt run model, and that's all. Main operator, pretty simple, responsible for building the model. As I have said, we can use dbt test for validate or for validate quality. So for some complex model, we can use model test group, like dbt run model, and then dbt test that will validate that this model is correct. So, as you can see, now we have several task types in our deck, simple one and task groups. Another challenge we faced at Toloka.ai is DAG decomposition. At Toloka.ai we have around 1,000 models, 1,000 objects, and of course we don't want all of them to be in one DAG, one huge unsupported DAG. We decided to generate more DAGs, and each model belongs to a domain at Toloka.ai because we use data mesh approach. At data mesh approach, every model, every data object should belong to some data domain. And models can run at different frequencies. So DEC is a combination of domain and schedule. Here you can see the result on the slide. There are several domains like Toloka backend, Toloka frontend, Toloka backend, and etc. And some of them have different schedules, like Toloka backend daily, Toloka backend hourly, and so on. So there are a lot of. Don't look at the mistakes, errors. The most beloved part of this, as for me, is that we don't need to think about dependencies. So all the dependencies are resolved by dbt. We don't need to think about dependencies. We just need to generate DAG correctly, and that's all. It's really cool, as for me. So let's go through the MPF generated DAG. Schedule, where the flow should run, generate based on dbt model metadata. Tasks generate based on model complexity. It can be simple model run or some complex task. Task dependencies generate based on dbt build output as Airflow sensors. And callbacks, we registered dbt model as Airflow.set, so we can use Airflow callbacks. Here on the slide, you can see complex model task with sensors. It can be external sensor for some other DAG or direct dependency to other model task group, and a complex model task group with test and dbt run models. Here's an example from Airflow. It can be complicated, like here. I think it's the most complicated task group at Toloka.ai. Data mesh domain. At data mesh, domains can be divided into 2 classes: domains aligned with the source and data domains aligned with consumption or analytical domains. So here's an example of classic source domain related to source, and everything is pretty simple. We just read raw data and clean them. And here's an example of some analytical consumption domain generated. The domain requesters daily. There are a lot of dependencies, a lot of data marts, so analyst can create something special here. Conclusions about our library. So idea is very simple. We already have a graph in dbt, and based on it we can create a DAG. And using this approach, we can use dbt and Airflow together. And using them together allows us to leverage the advantage of both these tools. It also provides a convenient workflow for both developers and analysts. So analysts can focus on business logic and SQL queries, and data engineer can focus on Airflow cluster, data ops, scheduling tier, etc., etc. So, as for me, it's pretty cool. As I have said, you can use our library, DMPIF. To be honest, there are competitors like Cosmos library from Astronomer. I don't have enough time to compare and to say that our library is better, but maybe next time. Let's go to the third part. Third part about agents, where agents comes to the stage. So everything worked fine. Believe me, the MPIF worked fine. Everything was great until LM agents appeared. So analysts came to us with their own agents, and they expected everything to work. Did it work? Of course, it didn't. It didn't from scratch. So we had another task, another challenge. We had our code repository, dbt plus Airflow, 1,000 models, plus minus dbt lineage, and we have to do our agent to understand the project structure, to find dependencies, to review PR, and etc. Everybody now wants from agents. And of course, we had the constraints, limited agent context, standard connection protocol, and do not break the analyst workflow. What was our first approach, first attempt? Another simple idea, let's use dbt MCP. dbt released MCP server, it open source it, everybody can use it. And at first, it seemed to be a great solution. So one line to add dbt MCP to your agent, 59 tools were available, everything looked great. However, pretty quick we found a lot of problems. First of all, Cursor has a tool limit. Cursor sees only 40 tools, so 59 is too many for Cursor. Another problem is tokens. 25,000 tokens were already consumed even before the first request. It's too much. And another problem, I think the main one, it didn't work well. So dbt MCP didn't work well, and the best tools, of course, the best tools are paid. You should use dbt Cloud. We don't want to pay money to dbt Cloud, so we decided to make our own MCP server. Let's start from the question, what is MCP? MCP is an open protocol that enables AI models to interact with some external tools. So here you can see some schema about MCP. It looks simple, and you can think about MCP like an API layer. So we can use pretty known CRUD-like interaction between API, between agents and API, create, read, update, delete. It's a pretty famous approach, and we will be wrong. Don't use CRUD approach. There are a lot of articles about it, Anthropic, Redis, some other. I bring a list of articles. So CRUD approach is bad for agents, and I will show you why. I will show you why based on dbt MCP. Let's imagine we have like an ordinary task. We change something in our model, and we want agent to understand is there any problems here. Let's think like an agent. So what's going to break? I am an agent, and I am looking through dependencies. I see a lot of tools. In which one do I call? And honestly, I don't know. List models, get model details, get lineage, get model children's. None of them is quite fit the request. The request is what's going to break. Maybe I should run some commands like dbt compile, dbt build, dbt run. Is it destructive or not? Spoiler, yes it is. If agent run dbt build full refresh, it can break prod. Nobody wants prod to be broken. So what is the right approach? The right approach to build MCP is so-called compound tool. Main idea is pretty simple. I think you can see I love simple ideas. Main idea, one business process is one tool for one business process, and that's all. Let's go to our example. Is my branch ready to merge? And agent, I am as an agent, should only find the only one tool, review branch, and that's all. And this tool could encapsulate very complicated logic, like diff branches, maybe some impact analysis, cross-domain risk, and summarize. But all this logic should be inside the tool. Agent should not think about orchestrating or something else. Another good approach is to make description as a prompt. So description of a tool should not be documentation like TPT did it. So it should be prompt, and for us worked this structure: when to use a tool, then some instructions what other tool to use, and some examples. Examples it was pretty important to add. If we are talking about implementation, implementation is not complex. We used FastMCP, so you can see that we just registered some tools, then agent can list the tools to use, and then decide to use some tool, like here, review branch. So it's very easy to write, as you can see. So some conclusions on MCP patterns. A list of use case, not API points, it's very important. One tool per use case. You should combine internal calls inside the tool, so don't delegate it to agent. Descriptions should look like prompts, not documentation. Cross-reference between MCP tools, and of course limit the number of tools, save context. Live demo. I'm not brave enough to have live demo. I have a video. Can you help me? I just want to show you the magic, that everything works. I want to prove it. Okay, here you can see Claude and simple request. We shipped email verification, and we want to expose email verified flag somewhere. Open PR, give me a review, what's affected. And here you can see what agent do. He use create branch, search models, into tools. We have at our MCP. Let's give him some more time. Read files. He's searching for models. What do you think about agents? For me, it's like a magic. I'm still like a magic. I think all the world divided into two parts: AI haters and AI believers. So I'm AI believer. I like it. And he's thinking, changes. Review branch, impact analysis, a lot of stuff. So you can see it's the answer from our MCP server. And here is the result. As you can see, blast radius, our agent found 77 downstream models from many domains, and he found some risks. And I think the second one is pretty interesting. So user SCADA is a snapshot, so it's a SCADA 2, schema evolution, and we should think about it. So, thank you. No. Okay. No, it's not that. I have some takeaways for you.
Okay.
It was applause that nothing has broken. So takeaways. Airflow versus DBT. You can use both of them. Great tools, DBT is great, Airflow is great, use both together is even greater. Simple idea, we already have a graph in DBT, we can generate DAG based on this and a lot of great stuff. Of course there is a weaknesses, it's another additional custom built integration library, but you can use our or Cosmos or any other. Some MCP pattern conclusions, like you can use, you can follow our library, it's Nasdaqov, and our site. Feel free to reach us. Contacts are here. So, and that's all. Now that's all.
Thank you. You know, I'm not a hater, but like, if someone about like 6 years ago would have told me, you know, like we will be applying changes to production database using a template engine running in Python for generating SQL queries, and all of that will work through AI, I would say something like, hey, yeah, bro, okay, of course. So, yeah, thank you. Do you think it's actually safe like to do these things? Like if we are actually pointing at production database and we run like AI, is it safe to run this?
I think it's safe if we are talking about some peer review, some documentation, and something like this. I'm still afraid to think about agent like a junior specialist who has access to production. So no way.
And also, I believe DBT also allows you to write models in pure Python, right, and not in SQL. Have you ever used that? What do you think of it?
We did use it. At first, I think before 1.4 version of DBT, it was SQL only. It was like a slogan, SQL only, nothing more than SQL. After 1.4, they adopted Python for some models, Python models, but it's second citizen still. It's still second citizen, as for me. So we used it, but I didn't like it.
So are there any people in the audience who work at Fivetran, by the way? No? So Fivetran just recently bought DBT, right? Do you think that's a good thing or a bad thing? Because there's nobody here.
It's complicated, I think. Complicated because, if DBT core still will be open source, it's okay, no problem. Yes, but they have an opportunity to close it, and I think data community afraid of it. So I am afraid of it. So
once again, as an open source, we'll fork it and we'll support it.
Yes.
We'll see.
We'll see.
All right. So, any questions to Evgeny about this? How DBT? So, how many of you are actually using DBT? Some people. Okay, interesting. Honestly, I would say this is a pretty mainstream way of doing transformations right now, even like in data warehouses and stuff.
So you have a homework. After that, you have to touch DBT. It's awesome. Yeah, it's really awesome.
Yep. So really, no questions. Everybody's tired. All right.
Hello, thank you for such an amazing presentation. And my question is more about MCP. When you build it, did you think, or maybe you already implement some guardrails to avoid it, to do some destructive actions like deleting or this full rebuild that you mentioned?
We avoid alloying. So there were no destructive tools in our MCP. So no destructive tool at all. So I think it's the only way to avoid any destruction. No destruction tools, no pain.
So there is an interesting thing that I've recently read about MCP and about how people approach this. Like, for example, if you run a complex tool like DBT on a database, DBT, I mean, by itself, it allows you to do a lot of things. And this usually means that underneath, there will be several tools accessible for the AI. Also, sometimes, to make proper decisions, I also need to have access to table descriptions, like some business meaning behind these things, and so on and so forth. So, and we actually have two things in the world of AI right now that can help with this. So we have tools as a concept within MCP, and we also have RAG as an external memory. So there was a recent paper about combining them together. Meaning, like, one of the things is if you run an MCP with a lot of tools with descriptions, you are in fact contaminating the context of the model, right? But we actually have RAG, we have vector databases that can allow us to select the things based on how similar they are to what we are trying to do. So instead of just keeping all of the tools and all of that in the context, we can use RAG to try and find specific tables, specific tools, specific pieces of context that you want to work with, and it really helps. Like they've seen there was a really big improvement in attention keeping within the model. So because the context is not contaminated anymore, at least not as much. So. Pretty interesting. All right, that's it. So yeah, thanks again to Evgeny. And yeah, I would say this is where we would wrap up. We are actually planning a lot more events like this. We're planning them for autumn. If you guys are curious, if you want to maybe give your own talk, if you want to brainstorm ideas, if you're unsure, feel free to reach out. We can discuss this. We can help you to work on your presentation, on your delivery. And yeah, and thanks once again. Thanks to a great team that made all this happen. And yeah, we'll be seeing you on our events, hopefully. Thank you.